This is about myself, an introduction slide, but of course, Mr. Ujwal has in an elaborative manner introduced me to you, so there is no need for this slide again. What are the things we are going to discuss today? In this session, first we will discuss about what is fire. A tidbits about fire. There is certain historical events about the fires, chemistry of fire, types of fire, fire extinguishing medium, hazards in firefighting, prevention of fire, what is fire safety, statutes, that is law about fire and safety, SOPs, that is standard operating procedures, and the protocols. So the system what we follow, all these topics we will discuss in a brief manner. Session is for 2 hours duration, and certain slides are only for your reference only, and most of the slides we will discuss, and based on time we will adjust the program. Okay. What is fire? So all these flames, whatever you are seeing in the screen, are fire only. Maybe of different kind, different usages. So like a lamp, a matchsticks, a burner, welding. This one is a industrial furnace. The top, bottommost one is a forest uncontrolled fire. This is a gas fire. All these activities involve some combustible actions. Combustion is the cause to produce fire. So fire is the visible effect of process combustion, a special type of chemical reaction. One point I would like to share with you, the center one, what you are seeing this, what is this? I think you can follow my cursor, I think. This is a simple matchsticks. In the match box, you would have observed that in most of the boxes, there will be one mention as a safety matches. What does it mean? There is something or there unsafe matches also. So the matchbox we are using is a safety matchbox. What happened since the year till the year 1862, matchbox, if the matchsticks rub with any material or with the stick with another stick with another matchsticks, it will catch fire. So it was very unsafe to handle. In a single box, we can have one matchstick, or we have to provide a layer of coating over that matchstick to keep it in a single box. It was the history, because the composition of the matchsticks was white phosphorus and potassium chloride. All these things are put together in the matchstick head. Then they invented to segregate these two elements. That is, phosphorus was attached to the side of the matchbox in the side manner, where we are rubbing, and on the stick head, the match head, potassium chloride and glass pieces are attached to glass powder are attached to the head. So when this potassium chloride, we rub it on the side of the matchbox where phosphorus is available, it catches fire. Before inventing this, after this only, the matchbox is called as safety matches. Before that, all these ingredients are put on the head. So whenever they strike, get a chance to strike or rub on any object, it will catch fire. So it was, those days were unsafe matches. How our forefathers used fire, or they created fire? Have you ever thought of this? Fire for early human, they may have used pieces of flint stones. That is the stone, if you rub each other, spark will come. Banged together to create spark. Fire provided for what they used the fire for: warmthness, light, and to keep the wild animals away in the night. Fire was used, as per our history, around 1.5 million years ago, fire was invented. The first fire, they think, still date, we assume that lightning was the first source of fire, the natural source. Paleolithic people discovered how to make fire. That is, Paleolithic means around 2.5 million years ago, Stone Age period it is. 2.5 million years ago, they started to use the fire. They produced fire by friction, as well as using the flintstone or iron pyrite. You must remember, fire is a good servant, but it's a bad master. Definitely, every one of us would have experienced this also. Fire gives warmness to us. It mystifies, that is, confuses also, delights us. That is, for joyfulness also we are using fire, and sometimes it terrifies. But without fire, there is no life, because fire is the source of energy for the entire universe. For the earth, we receive energy from sun, and in the earth, we produce fire for our energy requirement. Earliest fire would have been created by lightning. Controlled use of fire was traced back over a million years ago. And around 7,000 years ago, regulated usage of fire has come into force. That is, our forefathers have started to use fire for a particular purpose or for a cause. Fire, fire for cooking, light, land clearance. That is to create fertile land. They destroy land, destroy forests. For that, they set the forest in fire for agriculture purpose, and for in the war field also they use fire. Warfare as warfare also. We'll see what is chemistry of fire. Fire is caused by the oxidation reaction of some fuel. Oxidation means it is combination of oxygen or removal of hydrogen. That is oxidation reaction that you all must be knowing. Fire is a rapid self-sustaining oxidation process and release lot of heat and light of varying intensity. The intensity varies based on the quantity of the fuel as well as the quality of the fuel. Fire results from combination of fuel, heat and oxygen, that we call it as a fire triangle. Unless these three components are meet together, that is oxygen, heat, fuel, all these three, unless they combine, fire will not take place. What does it mean? If you remove one hand of this triangle, either oxygen or heat or fuel, fire will not sustain to continue to burn. So it gives a clue for us to put off a fire. We need to remove any one of the handle of this fire triangle, either oxygen or heat or fuel. Fire results from combination of fuel, heat and oxygen. At the ignition temperature or temperature of combustion, the material, this ignition temperature, temperature of combustion, all these things will see in the following slides as the definitions. The material will get ignites and continue to burn as long as there is fuel, the required temperature and supply of oxygen. So as long as we have oxygen, heat, fuel, the fire will sustain. Sources of ignition are the heat produced by chemical reaction. Chemical reaction in the exothermic chemical reaction can create lot of heat energy. It can give a fire. Electrical energy by short circuit, or purposefully we are deliberately creating heat energy by using electricity. Mechanical energy mostly by friction. For a fire to be self-sustaining, the oxidation process should be self-sustaining. If the oxidation process is not continuing, the fire will get put off. The ignition that triggers the oxidation reaction between one tiny bundle of oxygen, that is, you consider as a one molecule of oxygen, there is a tiny bundle of oxygen, and one tiny bundle of fuel, must produce enough energy. That is, the moment we have ignited one tiny bundle of oxygen and fuel, so we create and we give energy to burn, it started to burn, then it produces energy. That energy should be sufficient enough to ignite the next tiny bundle of fuel, oxygen, and the energy to create the burning. So how, if it continues like this is considered as a continuous chain reaction. So in the fire triangle in olden days, we used to say that only three hands, that is oxygen, fuel and heat, and the later development is chain reaction. Unless the chain reaction sustains, unless the first particle of fuel get burned to produce excess energy to induce fire on the next component of the fuel, the fire will not continue. That is called a chain reaction. This is the latest phenomena we follow. Latest means around 15-20 years. The material must be heated sufficiently to produce vapors. You must remember that whatever the component, whether it's a solid or liquid or gas, if we need to burn those fuel, first process taking place is it is getting vaporized. Even a wood piece, if you wood is heated, vapor will be produced from that. That vapor only will burn. It's not a direct solid fuel is burning. It is only in vapor. So ignition temperature, the temperature at which the vapor will ignite is the ignition temperature. That is the heat energy required for initiating the fire. If the source of the heat is an open flame or spark, it is not automatically taking fire. If you give a flame by a matchstick or ignition, then it is called as piloted ignition. That is something is being piloted to catch fire. For example, gasoline, that is gasoline is nothing but petrol we use in our vehicle. Its flash point is minus 42.8 degrees centigrade. Minus 40 is below zero, minus 42.8 degrees centigrade. And the ignition temperature is 280 degrees centigrade. What does it mean? That is from minus 42.8 to this ignition temperature, the gasoline is capable of producing sufficient vapor and catch fire if it is piloted ignition. That is, some source of ignition is, if you give some source of ignition for that. The chemistry, normally carbon combines with oxygen to give, in the oxidation reaction, gives carbon dioxide. During the process, it gives a lot of energy, heat energy. Suppose you are admitting or supplying the oxygen in a limited quantity, then it will be converted into carbon monoxide, that is CO. That means it can consume one more element of oxygen, that is the carbon monoxide itself can be used as a fuel. Carbon dioxide is completely burnt. You cannot use it furthermore for as a fuel. It is actually, in fact, it's a extinguishing medium for fire. Like that, hydrogen also burns with the oxygen, combines with the oxygen, liberating a lot of heat energy to form water. This is the main chemical reaction taking place during any kind of fire. What is heat? Heat is defined as the exchange of energy between system and surrounding. From one system, heat is transferred to the surrounding. And the direction of transfer of heat direction is from higher temperature to lower temperature. That will be the direction. Flash point is the lowest temperature at which its vapors ignite. If an ignition source is given, that is at flash point, it will not catch fire automatically. Suppose we give a ignition source, a spark or a flame, it will catch fire. Fire point means fire point is the lowest temperature at which the vapors keep burning even after you remove the ignition source also. It will continue to burn. What does it mean? That is, it is able to generate sufficient energy to induce the ignition of next element, every element in the sequential reaction or the chain reaction. What is pyrophoric ion? Industrial employees might be aware of this. Pyrophoric means any metal particle, if it is finely divided or it is crushed or sliced in a fine manner, if you allow it to oxidize it, when oxidizing takes place, it becomes pyrophoric. Pyro means a heat or fire. So when it comes in contact with the air, atmospheric air, automatically it catches fire. That is, its auto ignition temperature is our atmospheric temperature. For example, the iron gets rusted in the sulfide environment, sulfur environment, iron sulfide, and if it is finely divided, this iron sulfide forms over the iron structure. This, when it comes in contact with the air, it catches fire automatically. That is pyrophoric ion. For other examples are plutonium, uranium also having the same property. Combustion, what is combustion? Combustion is an exothermic reaction. Whatever the reaction, whichever the reaction which liberates heat is exothermic reaction. Self-sustaining, involving in a solid, liquid and gaseous fuel. Usually this is associated with the oxidation of fuel by atmospheric oxygen with the emission of heat, light or both. Another phenomena is flammable limit. See, we all know that lot of fuel, then lot of combustible components are, we know a lot of combustible components. Let's say let us take as petrol. Petrol is combustible. If you set it on fire, definitely it will catch fire. But at what concentration range? It it catches fire only at a prescribed concentration level. Only it will catch fire. That is determine its flammability level. There are two extreme ends. One is lower flammable limit, and another one is upper flammable limit. When the vapor composition or the vapor percentage, gasoline vapor or petrol vapor present in between the range of lower flammable limit and upper flammable limit, then only it will catch fire. When it comes below the lower flammable limit, for example, this gasoline flammable range is 1.4% to 7.6%. That means in the air, 100 milliliter of air if we take, in which 1.4 milliliter of gasoline is present, it will catch fire. Like that, if the gasoline concentration is rising up to 7.6 milliliter of gasoline, it will catch fire. That is the flammable range. Suppose gasoline is lesser than 1.4 milliliter, say 1 milliliter in 100 milliliter of air, then it will not catch fire. Likewise, if gasoline concentration is more than 7.6, there is over and above the upper flammable limit, then also it will not catch fire. It is, if it is less than the lower flammable limit, it is called as, it is too lean to catch fire. That's very lean mixture. That fuel supply is not sufficient. Whereas when it crosses the upper flammable limit, it is too rich to catch fire because the oxygen presence is not sufficient to induce a oxidation reaction. That's why the flammable range is from lower to upper flammable limit, in between area only. See in the curve, if you see, the x-axis is temperature and the y-axis is the concentration of vapor. In this, whatever the material, whether gasoline or kerosene or LPG or whatever you like, you take it. See, the lower flammable limit is fixed here and upper flammable limit is fixed here, and temperature also provided. What does it mean? See, less than this area of concentration of the fuel, there will not be any fire. As well as right side of this vertical line, the mixture will be too rich to catch fire, then also there will not be any fire. So any safety device or any equipment is safe to do any work, is made safe to any work, is determined by its lower as well as upper flammable limit. Major causes of fire in industries. In most of the industry, almost in all industries, we use fire for the purpose of energy, to initiate a reaction or to melt some metal or to do some heat process for metal, something for many things we are doing, we are using heat energy. So the causes in industries, and that's why we have to use very safely it. Combustible material storage area with insufficient protection. Suppose if store a lot of combustible oil or gas or explosive mixtures in a insufficient protection, that is not properly covered, or keeping very closer to the hotter surface. If this happens, it will be a cause of fire. Handling open flames very nearer to the combustible material like candle or any other open flame. Flammable liquid and aerosols. Aerosols means a fine mist of the flammable liquid. If we spray some body spray or something else we are spraying, even nowadays we are very frequently using sanitizer, it's also a flammable component only. If you press it, it comes out with the aerosols, that is in fine particles. If it comes in contact with the fire, definitely it will catch fire. Flammable liquid and aerosols, flammable solvents stored without protection. Chimneys means that the exhaust pipe of furnaces is not cleaned properly. Lot of soots will accumulate inside the chimney, that will catch fire at one point of time. Electrical poor wiring, battery, leaking batteries, acid will leak. It can cause some, induce some reaction to catch fire. Electronic and electrical equipment not designed to use in particular zone. It's a separate topic. We can discuss in detail about the zone. Briefly, I say every work environment is divided into 3 zones. There is zone 0, zone 1 and zone 2. Zone 0 means there will be always presence of some combustible vapor or metal will be there. And if any incident happens, it will be disastrous. That is zone 0. Zone 1 means occasionally combustible material will come in contact, and if anything happens, the accident will be bigger. Zone 2 means generally there will not be any combustible material, area is safe. Even if anything happens, the duration or the intensity of the incident will be very, very small. That is zone 2. That means zone 2 is more safer. Accordingly, the electrical equipments are designed to use in which zone? Zone 0 means you have to have proper insulated, and there should not be any contact with the environment and inside the core or the components of the electrical equipment. In such a way it should be designed. So the equipment should be designed appropriately in a suitable manner for the particular zone where we are going to use. Housekeeping also an important factor. Now we'll see type of fire. Our Constitution of India provides detailed provision for the rights of the citizens for safety and health, risk at workplace, and provide measures so as to ensure safe and health working conditions for every workman and women in the nation. Indian standard for as per BIS standard 2190/2010 classifies the fire as follows. You would have seen that in the fire extinguisher, a lot of alphabets are they used to display like A, B, C kind of thing. So we will see what is type of fire. So A fire means the fire which can, so it's a shortcut method I am telling you. A fire, after a fire, whatever the component in fire can produce some ash. A for ash, you just keep in mind, ash, that are all A type fire. Like wood, paper, waste material, all these things are A type fire, which can produce ash after burning, reduced to ashes. Cooling effort is more than sufficient to put out the fire, so mostly we use water. Class B fires involving flammable liquids or liquefiable solids, where blanketing effect is essential. This B fire is a boiling, liquid is boiling, so it's a boiling fire, liquid fire. Here, if you refer certain books belonging from America, USA, they describe B type fire as liquid fire, as gaseous fire. Whereas European Union, Australia, and India classify B fire as a liquid or liquefiable solid fire. We should be very clear that when we follow the standards, we follow the standard of Indian standards only. Indian standard matches with the European Union and Australia standard. Only USA is following a different standard. We need not bother much about it. Class C fire. In Class C fire, we consider this is a gaseous fire, whereas USA consider C as a electrical fire. They classify, USA classifies Class C as electrical fire, whereas we follow European Unions and Australia follows C is a gaseous fire. Fires involving flammable gases under pressure, including liquefied gases, where it is necessary to inhibit the burning gas at fast rate with an inert gas, powder, or vaporizing liquid to extinguish. That is C type fire. Class D fire is those who are working in metal industry, they may be aware of it. Fire involves metals, combustible metals such as magnesium, aluminum, zinc, sodium, potassium. All these fires are classified as Class D fire. Normally, this type of fire are fight with dry chemical powder. like and sodium chloride or copper based granulars we use. Sorry. Next one is class E. That is, this E is not clearly classified anywhere. We call it as a electrical fire, but when you consider a electrical fire, what do we say? The moment you switch off or trip the electrical supply to the system, it automatically changes from electrical fire to the fire material which involved in the fire. That is, suppose it's a wood, then type A fire. If it is a gas, then type C fire. Like that you will convert. So that it is as long as you disconnect or de-energize the system from electricity, it is considered as a electrical fire. So the classification, normally people don't use this class E as a electrical fire. It is a general term only. For electrical fire, we use carbon dioxide, that's a inert gas, as for a extinguishing medium. The latest addition is class F fire. There is cooking fat and oil. It happens on kitchens, not only at domestic, in a bigger level kitchens, in industries, hotel industries like that. So deep frying pan, all these are kept handling very hot oils. It can catch fire if the oil reaches its auto ignition temperature. So at that moment it will catch fire. The picture depicting at the right side is deliberately in a laboratory on a pan oil was kept and heated to allow it to reach its auto ignition temperature. The moment the auto ignition temperature reaches, the oil catches fire. After the oil catches fire, deliberately from safer distance, water was poured in. The moment water was poured in, water splashed over the oil to the outer atmosphere and the flame expands like this. That is, the entire area is in flame. It is a laboratory test method photo for this. So for this, we use only a wet chemical to put out the fire. Wet chemical is nothing but any chemical which can produce soap undergo saponification reaction and produce soap in the presence of the oil used on the pan is the wet chemical that is used in cooking. So this table describes you about the type of fires and what kind of extinguishing medium we use. This you can refer. Whatever we discussed so far only being displayed here. Okay. So fire extinguisher, will go to fire extinguisher. Fire extinguisher to extinguish fire as long as fire is under control. So if it, there, what does it mean? If it goes beyond control, fire extinguisher is not going to help. Fire extinguisher is here, we can say it as a first aid firefighting equipment. As long as the fire is under control, you can use the fire extinguishers. Very important thing is the persons available in the premises where the premises is in fire or in flame. The person should have been trained how to use fire extinguisher. That is very important in the event of fire. If they don't get that proper training, they will simply waste the fire extinguisher. It will not be properly used. If employees have not been trained properly, firefighting may get delayed, extinguisher material may go unused or waste and lead to consume more number of extinguishers. Fire extinguisher should be placed in such a way, where will you place? In such a way that the moment you see the fire, from the spot of the fire, you should not need to walk or run over 15 meter. In such a way that fire extinguisher should be placed. That means that every 15 meter, or if you take the middle of 15 meter, both side 15 meter, in such a gap, fire extinguisher should be placed. The person should not run here and there to find a fire extinguisher more than 15 meters. That is a safer thing. It's for industry as well as for buildings, big buildings also. See, these are the type of extinguisher. We will see in the later slides detail about the extinguisher. One is water. There is in the compressed air is filled, water is filled, and it is kept under the pressure of air. The foam, what is foam? We will see. Powder is, lot of powders are there. Dry chemical powder as a general name we will keep. CO2 is carbon dioxide, and wet chemical is for we discussed for type F fire, that is kitchen fire. Okay, so these are the different type of heat exchangers. Please note the point about the heat exchanger. Availability at the designated place. It should be checked whether the extinguisher is available at the place marked for it. Suppose somebody has taken it and keep it somewhere else, then when the real need comes, we have to search, we are looking for searching for it and wasting time. No obstruction to access or visibility. There should not be any obstruction to reach the fire extinguisher. Operating instruction should be legibly and facing outward. Safety seals should be intact. If it is removed, then the pressure may not be there inside. It will not help in the emergency. Whether it is full, that should be checked. Fullness determined by weighing or lifting. That is, just by carrying, you can feel the weight of the extinguisher. Examination physical damage like corrosion, leak, or clogged, or the damage in hose, something that you can see physical damage. If pressure gauge is available, whether it is showing the range required pressure, that also should check. Condition of tires, wheels, carriage, hose, nozzle should be checked. Where the wheels and tires are coming, very bigger size extinguishers are kept over rally, that like a truck kind of thing. So then the wheel should be proper. Then only we can push it to the required place at the time of emergency. These are certain devices we use for firefighting. This is a fire hydrant, double head hydrant. That is, two hoses can be fixed here. This is a single head hydrant with manifold. There is one header, manifold. Here also single head with two fold, and this is the hose reel. This high volume long range monitors, HVLR, abbreviation is HVLR. Using this HVLR, we can throw water for a long distance of more than 85 meters, and the capacity is 2000 gallons to 4000 gallons per minute. Please note, 2000 gallons to 4000 gallons. We all know that 1 gallon is approximately equal to 3.75 liters. So you just multiply and see the capacity or quantity of water we can throw at the fire accident place using this high volume long range monitor or HVLR. This is both manual operated as well as motorized using the remote also there. We need not go to the spot. Standing safely away from the fire scene, we can operate. That is, we can turn the direction up, down, and swivel in the side direction, and we adjust the flow pattern also, like spray or jet or nozzle, like that we can do. This is the left one side is the manual one. We can operate this for the same capacity. How it is effective and useful at the time of very high intense fire, that you can see in the later slide. And before that, these are the certain photographs of fire water sprinklers. The purpose of fire water sprinkler is the most dangerous or vaporized evaporative high volatile material stored vessels. Suppose due to any reasons any gas leaks or any fire occurs at the nearby place, due to that heat intensity, this stored vessel should not get heated up. If such a situation arises, automatically these sprinklers will start to spray water on the entire outer surface area of the vessel, so that the vessel will be kept under cooled condition. For this, on the tip of the sprinkler, the red color one, are you able to follow my cursor? This red color one is a bulb. It is a heat sensitive bulb. The moment the heat rises in the area, the moment the heat started to rise, this bulb will break in the temperature. Once this bulb break, the solenoid power supply will energize and this valve will open. This valve will open and will start to spray water even in the absence of manpower there. That is, in the remote area also, this will work and save the entire system. Another thing is, You would have observed that storage of oil vessels, oil tanks, very big oil tanks. Very big oil tanks, there are many types of oil tanks which are a cylindrical vessel, and the top of it roof will be there. In certain type of oil, the roof will be fixed, and in the lighter grade oils, the roof will be floating on the oil itself. Whenever oil level goes down, the roof will go along with the oil level, and when it comes up, oil level builds up, the roof will also coming up. So if there is a movement, there must be some gap between the roof and the tank shell. Otherwise, the movement will not take place or rubbing will be taking place. So once a gap is produced, this lighter oil will capable of getting evaporated and the vapor will come out. That means if you consider this is a floating roof tank, floating roof, and it moves along the periphery of the tank, and this portion is the gap between the tank shell and the roof. So due to sunlight, this portion of oil will get evaporated, and on the roof always some vapor will be get accumulated. In this situation, if a lightning strikes on this area, immediately it will catch fire. The moment it catch fire, oil fire, it is not simple to put off it because continuous supply of fuel will be there. Oxygen from the atmosphere will be available. Heat from its own source, the heat will be there. We cannot break the triangle. So what happens? This will continuously fire. So to put off this, there is a system, protection system as rim seal protection. So that we'll see how it works. Mr. Ujjwal? Mr. Ujjwal?
Yes, sir. Yes, sir. I will play the
This
video.
slide you have to play.
Yeah.
So that the rim seal protection that we just we saw the video in which suppose
Sir, you can start the slide, sir.
yeah,
You can
okay.
share the slide, sir.
Okay, now my slide is viewable. 28th slide.
No, no, not sir. You have to again share the
Oh, again
slides.
share. Okay, okay,
Yeah, I have given you the presenter, right, sir?
okay. Okay.
Yeah, it is okay. Now it is on, I think, 28th slide.
Yeah.
Fire
Oh,
proximity suits. Now it is again come on first page. Yeah.
okay. So in that slide, we saw that when the vapor is get accumulated, possibilities are there. If a lightning strikes or any inadvertent accident takes place, this system will automatically sense. And as we seen in the discussed in the sprinkler, one bulb is getting broken the moment the temperature of the environment rises, and it initiate water spray. Like that here also, one bulb, say temperature sensitive bulb is getting broken, and it sprays the pressurized vessel which contains the halon gases to put out the fire. It's a latest development. The other thing is fire proximity suits. So these suits, to fight, when we want to fight a fire, we can reach very close proximity to the, not into the fire. Please understand. It is a proximity suit only, not the fire suit. Fire suit is different. It is also available. So this suit is a one-piece suit with gloves, hood, visor, and shoes. It allows the wearer to work close vicinity of fire. It gives protection to the wearer. It has a back pouch to accommodate breathing apparatus. So breathing apparatus, you all must be knowing from industry, that which contains pressurized air which supplies for our breathing, controlled breathing. This is a fire entry suit. The difference between fire proximity and fire entry suit is, this fire entry suit is made up of mostly asbestos material which can withstand temperature up to 2000 to 3000 degree Fahrenheit, not centigrade, Fahrenheit. The facility available are both are same. Only thing, it withstanding temperature capacity is very high. It should be used only by the trained persons, because once you fit the suit, it's not easy to walk and move or view or to communicate with the people who are behind you. It is not easy unless you are trained properly. It is not easy. It will look like a man going to space. It will be looking like that. We'll see the firefighting medium. The most common, cheapest, and abundantly available firewater medium, what is that? It is nothing but water. Why water is so easy to put out the fire means, for putting up fire, what we are going to do? We are going to remove one of the handle of the fire triangle: heat, air, or fuel. Here you remove the heat. That means you are going to cool. You are reducing the temperature. That means you are going to use some material which should capable of removing the heat. Here water, it's latent heat. Latent heat means that is the heat required to change its phase from liquid to vapor. Vapor form of water is steam. So for conversion into vapor, it takes 2258 54.8 kilojoule per kilogram of water. That means it takes consume lot of heat energy to convert its phase from liquid to steam. By observing this heat energy itself, it cools the environment. That is, for some purpose, if you are removing the heat, you are cooling the system temperature or reducing the system temperature. This is one point. Next point is, in the atmospheric pressure, water, when it converts to steam in vaporized, it expands 1700 times. That is, if you put 1 liter of water into the fire and the 1 liter of water becomes steam, it produces 1700 liters of steam. So the volume is exorbitantly increasing. So that much quantity, so how much steam is produced, that much quantity of air is displaced from that area. Then what does it mean? That fuel fire to sustain, it doesn't get the sufficient air or oxygen. So air is removed or replaced by the large volume of steam. Heat is removed by its natural property of high heat absorbing capability to change its phase. So due to these reasons, water is one of the best medium to fight fire of certain fire only, not oil fire, not all fire. For a given quantity of water, the surface is greatly increased by conversion to droplets. Instead of pouring water, if you spray it by making it a fine droplets, the area of coverage will be still furthermore. Studies and research indicates if you are able to direct the droplets from size of 0.3 to 1.0 mm, that covers a large area, and it is the most best result you get. This is about water. See, we discussed about the long range monitor, fire monitor, long range high volume monitor. It's a hydrocarbon fuel tank. It is in fire. For this intensity of fire, for about 50 meters, I am damn sure no one can reach. Such a very high radiation will be there from this fire to that area. So how to fight this fire? Unless we use these high volume long range monitors, even without without human interference, that can be operated by using this only, we can put off this fire. This is a scenario of an actual firefighting scenario. The another component is aqueous film forming foam or film forming fluoroprotein foam. That foam is a component about the foam. When it mixes with water, what happens? Lot of tiny balloon kind of particle or a bubble kind of particle forms. Each bubble kind of particle is packed with air also. What happens when you consider the bulk volume density? Water density is more. If you take the density of foam as a single component without mixing water, its density is more. When both mixes, lot of bubbling takes place. This bubble comprises of air pocket also. So the bulk density is lesser than water, becomes lesser than water, less than 1 or 1000 kg per meter cube or 1 gram per cc, whatever it may be, the unit. So the advantage is foam start to float on the oil because its density is reduced. That is the main advantage of foam. Foam is a homogeneous mass of tiny air or gas filled bubble of low specific gravity, that is density. It contains protein concentrate or synthetic foam. The composition of foam is not much important for us. The mechanical foam compound shall confirm our BIS standard, IS standard 4989 classify this standard for foam. Foam forms a stable blanket and is capable of floating on the surface of flammable liquid. When you pour foam over the flammable liquid, this foam floats on the surface of the flammable liquid. What does it mean? It prevents or it creates a gap between atmospheric air and the flammable liquid. So this flaming from the fire triangle, you are removing the air. That means then the fire will not sustain, it will get put off. Foam forms a stable blanket and is capable of floating on the surface of flammable liquid. It extinguishes the fire by smothering, cooling, and continuous vapor sealing. Blanket protects the surface from the heat of flames and radiation from the other sources, thus prevent the vapor formation. Cools the burning surface with water, limits the supply of oxygen to burning surface. It forms a thin layer that floats on the surface of fuel. Keep in mind, foam shelf life is 10 years only. After 10 years, even we don't use it, we should replace. Industries sometimes they may hesitate to waste the foam because even after expiry also but in the event of emergency, it will not help. That is the main factor. For that purpose only, we are keeping the foam. Dry chemical powder extinguishers are primarily used to extinguish flammable liquid fires. That is very important for liquid fire. It is a non-conductor of electricity. It can be used on flammable liquid fires involving live electrical equipment also. The DCP extinguisher should conform the standard number IS 2171 1985/15683-2006 and higher capacity DCP extinguisher as per the standard of this number 10658-1983. What is the DCP composition? DCP means dry chemical powder. Potassium bicarbonate, magnesium stearate, magnesium carbonate, tricalcium phosphate. The calcium phosphate or silicon ensure this is very important. So all this powder we put together in a vessel cylinder, and if we keep it for a long time, if it becomes a bulk or a lump, what will happen at the time of requirement? It will not flow out. To ensure the flow, silicon component is mixed with it so that it will not form cake. Carbon dioxide is another extinguishing medium, that is CO2. It's an inert, non-corrosive, non-conductor of electricity, used fire involving in energized electrical equipment. Very important thing is when you use the carbon dioxide extinguisher, when it comes out of the nozzle, it creates lot of chilling effect because the carbon dioxide utilizes the heat available in the environment to get fully vaporized. So the nozzle or hose, the horn, like the thing will be there in the extinguisher. It will become very chill. Frostbite, a phenomena is there, frostbite. That is the very chill effect, very cold effect. Our skin will attach with the surface. That is frostbite. That may happen. One point. Another point is because of this chill effect, the outer surface will become wet. Once it becomes wet, because of the dirt or the impurities available on the outer surface of the horn, it may start to conduct electricity. So even though carbon dioxide is a non-conductor, this wetness created because of the chillness effect may conduct electricity. So care should be taken before using the CO2 extinguisher. Okay. Another problem is CO2 is 1.5 times denser than air. What does it mean? If you use a carbon dioxide extinguisher, it is going to settle at the ground level only. If it settles at the ground level, naturally it depletes the oxygen available for breathing. So the person who is there shortfall of oxygen, you will not have any feel before your giddiness or falling down and unconsciously. Suddenly people will fall. So that care also should be taken when you use the CO2 in a closed room. CO2 may displace oxygen and cause rapid suffocation. It may increase respiration and heart rate. CO2 is a clean type of extinguishing agent. It does not leave any residue. That is advantage. Mostly in industry, steam will be available. If you use a lot of steam, you can give a blanketing effect for air so that it is considered as a removal of oxygen from the fire source. It is like that it is used. Sand can be used to prevent spreading of burning liquids. Sand should not be used for extinguishing fires in rotating machines. That is very important. Fire blanket, when clothing a person, suppose a person near to the fire accident, he himself is in fire and his dress material caught fire, then this fire blanket, it is filled with a kind of jelly that can be covered over him to give the cooling effect, and he should roll on the floor to put off and get saved. This wet chemical already we discussed about the kitchen fire. In this, what happens if this gives a cooling effect, and the potassium salts are used to give the process of saponification, and the soap material form that is a non-combustible. Because of that, we are able to extinguish the fire in the kitchen.
Jairaj
Yeah,
sir,
yeah.
actually, please adjust your mic. Actually, earlier your volume is at higher side. Now it is coming at lower pitch. Actually, please adjust your this
Now it's
mic.
okay.
Yeah, it is okay.
Okay, okay. Two or three phenomena about fire we will see. One is boil over, slop over, and blew. This is very important phenomena for the industries which handle liquid flammable material. Suppose any liquid material, if we store in a tank, there will be a roof, but in due course of time, due to corrosion, or hole will be that corrosion will cause a hole on the roof. At a point of time during rainy season, the water may go into the tank. Suppose the material is not water sensitive, the water is going to settle at the bottom and it will be keep quiet and it will not give any harm to the product. But at the time of emergency, at the time of fire, what happens? When these tanks are in fire, what happens? The heat transfer, the flame will be on the top of the layer of the oil or the flammable liquid. The heat transfer from the layer to the bottom of that tank also, as well as to above the tank also. When it goes to the bottom, it keep on that quiescent burning, that is calmly it burn continuously. So in the quiescent burning, when the heat transfers to the downward and reaches the bottom, the water available at the bottom of the tank will start to boil. Already we discussed water will expand when it becomes steam 1700 times. So what happens? Suddenly water expands. This expansion cannot be taken care by the volume of the tank. So it throws away entire oil out of the tank, causing the flame to become very intensive fire. So it will be thrown out. Suppose people are standing near the tank, it may be thrown out on them also. That is boil over. That is the water settle at the bottom, gets boiled because of the heat transfer, and this suddenly expands 1700 times and throwing out. And the slop over is, if the oil is in fire, the surface of the oil suddenly start to expand because of any heat transfer will cause an expansion, thermal expansion. This expansion will increase the level in the tank and suddenly it will overfill or overflow from the tank, that will spread the fire to the outside the tank also. Another one is BLEAV, that is abbreviation, boiling liquid expanding vapor explosion. What does it mean? There is suppose a vessel which contains a highly volatile liquid, like we will take as a butane or LPG, liquefied petroleum gas, that is our cooking gas at our domestic kitchen. These LPG storage vessels, if it catches fire, what happens? Slowly it will get heated. At one point of time, the heat transfer to the tank shell, metal outer shell, and this outer shell transfers heat to the liquid inside the material, so that the LPG available inside the tank will start to boil and expands. At one point of time, because of the external heating, the metallurgy of the tank will get disturbed and it will start to expand widely. It will open to lead to a very big disasters. That is believe. Mr. Ujwal, you have to play this one.
Yes, sir. Thank you.
I will brief. Just to watch the flame and the black smoke, suddenly the white smoke start to come side. in the sideway. That indicates the water starts to boil and steam is coming. That is boil over. That's enough, Ujjwal. Yeah, give me the sharing, right?
Yes, Cam, sir. You can start from here.
Okay. The slide is visible now?
Yes, sir.
Okay,
Visible.
yes. So one incident is in 1984, November 19, a catastrophic explosion occurred in Mexico City, North America. The same that the next slide we will discuss. So before that, one more time I will say that in the previous slide we observed one video in which initially during the fire we could see only the hot flame and the black smoke, and after some time a white plume started to come out. That white plume is nothing but the water settled in the tank started to boil and started to coming out. That is the boil over. That steam, when it comes out, it pushed the oil also outside and spread the fire. That is boil over. Believe is, as we already discussed, this is only one case history. In the Mexico City, in one of the petroleum refinery, it started to fire, and the one fire started at one place, but because of this heat intensity, automatically the vessels adjacent to that area also caught fire, and 600 people were killed, 7,000 injured, more than 2 lakh people were evacuated from the area. Such a very severe incident it was. Um, so the belief is also a very high thing. Ujjwal, you have to play this again. Ujjwal? Mr. Ujjwal?
Yes, sir.
Yeah, this video you got to play.
Yeah, yeah.
40, number 40. This is a LPG storage vessel. Externally, fire is there. Outside, some fire, it caught fire. Ujjwal?
Yes, sir. Given the
Yeah.
rights.
Okay. So boiling liquid, expanding vapor explosion. This boiling liquid expands because of the heat. It expands. Its safety valves or safety devices open to control the pressure. When the heat is beyond its safety devices capacity, the metal start to get heated. Metal expands and exploded. This is also one type of fire. In case of fire, the safest thing is those who are not directly connected with the firefighting should move out of the area. That is safe and also a helpful point for the people who are involved in firefighting. Ignition sources defined as initial release of energy to trigger the combustion fire. Factors for ignition include temperature, energy release, quantity of heat, and direction of heat application. It is important to understand the source of ignition to prevent fire. So to prevent fire, unless we control the source, we cannot prevent. So electrical equipment, friction, open flames, hammering, sanding, scrapping, cutting, hot surfaces, lightning, automobiles ignition, chemical reaction, static electricity. What is static electricity? If you are aware of it, it's okay. Otherwise, in the question session, we'll discuss. Are the sources of ignition. Mobile phone also can be source of ignition. Electromagnetic radiation from mobile phones can ignite petrol vapor directly, or that it could include currents in the nearby metals objects and trigger a spark. That's why in all the petrol bunks, mobile phone should not be used. Such a board will be there. So types of firefighting system. We'll go to the firefighting system. There are two types. One is passive firefighting and active firefighting. Passive firefighting, what is that? Passive means without much direct involvement, some firefighting thing. That is a safety, inbuilt safety only. Fireproofing of structural members. That is, suppose some structures in which pipelines are there which carries the flammable material. Then the structure should be protected, or fireproofed material should be applied over that structure, so that even in the case of fire, the structure will not fall down. Pressure relief system should be very proper. And the flaring system. Flaring system means the excess pressure released should be directly going to a incinerator system or a system where it should be burnt completely. Blow down, that the excess level can be drained to somewhere else. Somewhere else means to safer area. Fire protective insulation should be provided for the electrical systems. Fire resistant thermal insulation. Fire retardant coatings. Fire retardant coating means the coating which either it prevents the equipment from the fire. Flame proof enclosures for electrical equipment. Certain enclosures are flame proof. If the area of their process unit contains combustible or flammable material, the electrical equipment used in that area will be flame proof. What is active fire protection system? These are passive, because inbuilt in the system itself. Even it will take care round the clock, 24/7, 365 days, the system will take care even in our absence also. Whereas in the active fire system,
Sir, please adjust your mic, actually, your mic. Yeah.
volume is high or low?
Now the volume is okay.
Okay. Thank you. Active fire protective system, this fire extinguisher, fire water supply system, fixed or semi-fixed firefighting system, mobile truck, all these are active fire protection system, because we have to activate these things. So methods of fire extinguishing already we discussed. Starvation. Starvation means we make the fuel is non-available to continue the fire. Elimination of fuel. Smothering, controlling or stopping the supply of air, that is oxygen only. Cooling means removal of heat. Chemical interference, that is interrupt the chain reaction. All these four factors are chain reaction, heat, air and fuel. All these four factors are important for sustaining a fire. Starvation is a removal of combustible material, fuel from tanks, taking out of cargo at a ship. In a ships also, when a ship catches fire, the immediate aim should be we should fight the fire. If it is not, it is beyond our control, then to the possible extent we should remove the cargo from the fire. Cutting off branches around the forest fires, closing the vein, valve and the gas fuel lines. you would have heard that in firefighting, one of the firefighting method for forest firefighting is when it is going beyond control. Sometimes it is continuously burning for days, weeks, months, and years also. In that, if it is uncontrollable, what they do, they set the same forest from the opposite side, set the forest in the fire. What happens from one end, actually the fire is taking place and it is traveling. And from other end, if you set a fire, you can confine the fire into a single area. It completely burnt out, and due to starvation, there is non-availability of further fuel or wood. It will get put off. That is one of the method. Suppose in the hutman's area, if huts are in fire, they fight the fire. At the same time, what we'll do, huts are normally very adjacent to others. In between 2 or 3 huts, they will demolish and remove. They create a gap, so the traveling of fire will be stopped. That is also one method of starvation only. By removing material on fire of combustible material, for instance, pulling apart a burning haystack or a thatched roof. By subdividing burning material to small sized isolated fires to break continuity. Smothering is removal of oxygen or preventing oxygen only. It is by using steam or carbon dioxide. This can be handled. Cooling is applying by water only. That is, you remove the heat. Chemical influence, some chemicals, the bromofluorohydrocarbons have a great affinity for free radicals. The free radicals are the main elements to continue the chain reaction. So to control these things, these bromofluorohydrocarbons will be used for intervening the chemical reaction. So how we are going to use an extinguisher? The extinguisher, you keep the acronym, that is PASS, P-A-S-S. Keep this in mind. P means in the extinguisher, there will be a pin or a cotter pin or a lock pin. That pin should be pulled out. This will break the seal. You should break the seal and you should pull out the pin. Then always to fight the fire, you should aim at the seat of the fire or base of the fire. It is not on the top of the flame. From where it is burning, the flame, that seat or base of the fire should be aimed. Squeeze the handle on the extinguisher and sweep across the flame. Sweep across the flame so that the entire area will get covered. Ujjwal? Ujjwal? Mr. Ujjwal?
Yes, sir.
Yeah,
Yes, sir. Yes,
this
sir.
slide.
Yeah.
But a very small slide only. Shall I play continuously?
What, sir?
I will play with a very small slide only. Even
Yeah.
audio
You can
also
play,
will
sir.
manage. Okay.
Yeah. You can play.
Please understand P. P for pull the pin. Aim at the base of the flame. Squeeze the lever. You squeeze the lever so that the powder will be released. Sweep side to side so that fire will be put off. This is the method to use a fire extinguisher that you must know. Suppose a person is noticing a fire. Who is the person who noticed the fire at first should do certain activities. Every industry will have their own protocol or SOPs how to behave. Everyone should follow their guidelines. But general guideline is the moment you want seen the fire, inform the fire control room if it is available. If fire control room is not available, whoever the authority responsible for fire, the person should be informed. For this, if fire call phone is available, use that phone. Or any intercom directly connecting that person, like hotline or any other line, is any means of communication like walkie-talkie, you use it. Or manual call point. This, in case of fire, that one red color box is there, no? This one. Are you able to follow my cursor? This is called as MCP, manual call point. Here, the center round is a glass material. Glass. The glass is pressing the red color switch and it is screwed. Normally, a small hammer or an iron rod will be hanging from here. The moment you see the fire, using that rod, should break the glass. the switch in depressed condition will get released. The red color switch, if it get released, automatically the communication will go to the fire control room. That is the system by this. And this is a hand siren. By rotating this, a siren sound you can create, and a walkie-talkie can also be used. All these things should be, all these communication systems should be appropriate one should be used to communicate first to get more help. Then the person should attempt to extinguish the fire using the available resources like water, fire extinguisher. Alert the people in that area to evacuate and ask them to go to a safe place or safe assembly point in the event of emergency will be there. It is an industrial guideline. Every industry will be there, safe assembly point. To that point, you should direct everyone to that place. And if the fire is manageable, you fight or try to avoid it spreading to other area. Fire emergency response, how it should be there? You just keep in mind the RACE, the acronym. Rescue clients in immediate danger. Whoever in the front face of the fire, rescue them at once. Shout as fire alert. If no equipment like phone, manual call point, walkie-talkie, siren, and nothing is there, don't wait for anything. You use your natural resource. Shout as fire, fire. Full fire alarm if it is there, dial phone and all if it is available. Close all doors and windows if it is a fire in an inside room. That idea is to, what is that? To prevent supply of air to the fire. It is one of the element of the triangle. So if you cut air, the fire will come down. It will come under control. That's why close all doors and windows. Extinguish, evacuate. Extinguish small fires. Evacuate clients if appropriate. So this race you should keep it in mind. Firefighting, when the firefighting crew is coming, how the people in that area should behave. That is, clear the driveway for the arrival of the firefighting truck or crew. That is very common. Coordinate with fire crew for isolating the source of fuel. That is, fire crew will come from the other unit, other department, or picked people, chosen people from various departments will join together and form a team and come. But the person who is actually operating the equipment only knows where it gets fuel for sustaining of fire, everything. So the person in charge of the particular unit should coordinate with the fire crew. Apprise the incident controller about the plant condition. Take a call for isolating power supply according to the situation. If the situation permits, isolate the power supply. Cool the adjacent facilities to prevent auto ignition due to heat radiation. That is very important. Continue to cool the system after extinguishing the flame. Do check for any damage in electrical cable before energizing. That is very, very important. Otherwise, some short circuit will cause another danger. Normalize the activities as per the concerned unit procedures. The incident controller must do a head count for the available persons and tally the same with the record of the time office or attendance. That is, in any emergency, any accident, after completing or normalizing the system, the first thing before starting the unit, one should do a head count. Anybody gets trapped in the fire or get damaged or anybody has fallen unconsciously, we have to rescue. By head count only, we can identify. So routine check, keep the inventory list of firefighting equipment and check for its availability at their designated location. That is very important. Do periodic check for every equipment and update the checked date on the extinguishers. Familiarize with the different types of alarms. Mark emergency exit route. That is very important. Extinguisher location, fire water hoses location, and communication system. Do mock drill to ascertain the preparedness of the team to handle emergency. This mock drill once in a while or on a fixed periodicity or frequency, mock drill should be conducted with the coordination of the entire employees of the industry. And suppose if it is considered to be a off-site mock drill, that is the emergency spillover outside the campus of the industry, with the revenue department authorities, you should get permission, and that mock drill also you should do. But keep it in mind, never attempt to create a real emergency to conduct the mock drill. Suppose you are assuming a situation as the situation your process unit is in fire, but don't set the unit on the fire. Recently, you would have read a news item in the during COVID-19 cases. One hospital it happened, serious thing happened. So that's why I specifically mentioned this point here. If on fire, best thing is stop, drop, and roll, because normally flame travel upward. So you drop down and roll. Smother the flames with a blanket if it is available. Move away from heat source. That is for personal. Now we'll move on to safety. This is all about the fire chemistry, type of fires, type of fire extinguisher, extinguishing medium, the methods we use, intensity of flames, all these things we have discussed so far. Now we will discuss about safety. We'll go a little faster because time is nearing to our target time. And if any doubts, question you have, you can discuss at the last session, end of the session. Fire and safety are the integral part of each other and inseparable. I think that's why the class is also designed as fire and safety class. Unless safety conscious is in mind, we cannot prevent a fire or fight a fire. Fire crew works to ensure safety of men, material, and contain the impacts due to fire accident. Safety focuses on prevention. Please keep it in mind. Prevention is better than cure. Objective of fire safety is to prevent a fire incident. In the event of its occurrence, aim to reduce the destruction caused by fire. Fighting the fire at its incipient stage is always easy. That is, at the early stage, it is always easy. The moment we notice the fire, we should attack. If we wait for something, it will spread. Then we have to wait for it to get extinguished automatically. You maybe remember that one incident happened at Jaipur in an oil terminal. The fire was put off after completely burning out all the available fuel only. We couldn't do anything on that. So such a thing will happen. If we notice it and start to act at the early stage, we can prevent. To prevent the fire accidents, the following system should be in place. Flame-proof equipment, proper ventilation, personal awareness, safe work practices, good housekeeping, anti-static measures, work procedures, right tools, all are the now in day-to-day activities we used to follow only. Fire exit route should be there, very clear, and at any cost, don't use that space for storing or storing any material in that area, unwanted material or wanted material, because the fire exit rarely we use at the time of emergency only. But at the time of emergency, if it doesn't use, we may not be able to save people. Exit route is a continuous, unobstructed path of exit travel from any point within your workplace to a place of safety. That means if you enter a exit door, even there is no light, if you keep moving along the pathway, you should reach a safety point, safe point. The exit route must be located as far away as practical from each other. Here, normally two exit routes should be there. Both should be placed in far away, because suppose a fire takes place near the exit route, the entire area will be under flame or smoke. So the next adjacent door also we cannot use. So if we keep the other one and the far away, using that we can escape for that only. Exit route must be permanent. An exit must be separated by fire resistant materials. The number of exit route must be adequate. Exit discharge must lead to directly outside. Exit door must be unlocked from inside. This is very, very important. Exit door should be kept in unlocked condition, not only inside, both sides. Recently, a week or 10 days back, you would have observed a news item. There was a fire in Bangladesh in an industry where people were kept locked inside. No one was capable of coming out because all doors are locked and they were working inside. Most of them got charred. A side hinged exit door must be used. Exit route ceiling 7.6 height and 28-inch wide. Lighting and marking of exit must be clearly visible. These are the basic things. See the exit routes. This is fire exit. Follow my cursor. How the area is used. This is not a created photo. It's an actual, during an audit, these photographs taken. Like this, things are happen. Normally it happens everywhere, but we should be very cautious to keep this area very clean and free from any obstruction. Escape route should lead you to a assembly point or meeting point. What are the things you should do? That also you should know. Fire order should be implemented in the premises with the roles and responsibility of all occupants. Any fire orders, the persons employed or in employment or in service should have a defined role. What are the roles they are going to do at the time of emergency? Everyone should be clear on it. Good housekeeping. All receptacles for waste should be emptied regularly. That is, waste bin or dustbin should be in empty condition. Otherwise, it would be used as additional fuel for the fire. Correct rated wire and electrical appliance should be used. Faulty electrical appliance should be repaired or replaced immediately. Hot jobs. Hot jobs means any job which can create a spark, welding, grinding, like that, rubbing. We can create spark or heat. Carried out under strict supervision. Keep the escape route free from any form of obstruction that we already discussed detail. Evacuation drill should be conducted at regular intervals. Impact firefighting training to all employees. Impact. All the employees should be trained. Fire safety equipment should be maintained in high standard and check at regular intervals. Don't plug too many electrical appliances in one socket if it is a office. Normally it happens. In the plant area, it doesn't happen. Mostly it doesn't happen. Don't store LPG gas cylinders more than the permitted numbers. Don't apply any paint on fire detectors, sprinklers, etc. because all are sensitive items. If you apply paint over that, it will not sense. Don't engage inexperienced contractors for servicing of firefighting equipment. That is very important. Don't think that fire safety is other job. One can never think like this because occasion may come. We may be in the flame. Don't relax after hearing fire or emergency call. Once you listen the emergency call, you should act very quickly, swiftly. On electrical safety, only trained maintenance employees are authorized to carry out troubleshooting. Don't attempt to do any maintenance activities if you are not trained for that. Always permit only authorized persons to do the work. Never use damaged electrical equipment. It's a very common thing. If the electrical socket is get damaged, then what we do? Normally we insert the wire directly into the plug point and put some wooden sticks into that to prevent it from falling. It's a very dangerous practice because in industry the load will be very high and the higher load the current will be very high. Never use electrical equipment in damp condition, that is in wet condition. For electrical safety, the lockout tagout system should be followed very strictly. Lockout tagout means before doing or starting any electrical work, de-energize it and provide a lock over the electrical energizing de-energizing breaker. How many locks one should put? A person who is owning that equipment. Suppose a person from operation or process department, he is operating the equipment, means he is the owner of the equipment. He should put a lock. And the person who is going to do a maintenance work, suppose if it's a pump mechanic may come and attend. So he will also put a lock. And the electrical person who is de-energizing the breaker, he should also put a lock and take the key to their own. So all the three keys, there is lockout. Then tag out means the person who does the maintenance work, that is a rotary or pump mechanic, he should ensure the job is completed and he should remove his lock and go away. The owner of the equipment will open and take the lock. And at the last, the person who is going to energize, the electrical person, he will remove the lock and then he will energize. For all these things, records and signing system should be there. There is lockout tagout system. If the system is followed, there is absolutely no chance for accidental energizing of the system and somebody is got electrocuted. Such a situation will not come. So the system should be followed very seriously. The electrical, when you open the breaker, flashover, metal melting because of that vapor, because contacts at higher temperature, very high temperature will be there. The moment you open, the flame will come out. That may spill over our face, or the charred metal or the molten metal may spray. All these things will happen. The temperature can be up to 20,000 degrees centigrade, they are saying. Prevention is de-energize electrical equipment, wear suitable PPE, personal protective equipments, keep at a safe distance, reduce the energy output from an incident, carry out a risk assessment, train on-site workers to control risk and interrupt faults. The safety zone already we discussed, that's why I skipped this slide. Okay, hazardous area, that is zone 0, 1, 2, and zone 0 is always explosive material will be present. 1 is occasionally, 2 is rarely. So according to that, the electrical equipments are designed. For example, one point I will tell that suppose if it is zone 0 where hydrogen is handled. Hydrogen is a flammable gas, you all may be knowing. H2 is its formula, and it is the lightest element among the total element. So what happens? It can enter into the all area. A small gap also hydrogen can infuse into that area. And the flammable range, already we discussed the low flammable range and upper flammable range. It is, for example, for diesel, it is 1.4% to something around 6.4%. Whereas for hydrogen, it is around 4% to 75%. So almost for the wider range, it is flammable. So if it goes into a motor and into the winding area, what happens? If any heat produced, the motor may catch fire, or any short circuit, any spark comes inside the motor may catch fire due to the presence of hydrogen. So in this area, what they do, they continuously supply a air connection to the motor inner casing or nitrogen. Any one of these will be supplied continuously with a pressure monitoring system, so that always it will be slightly higher than the atmospheric pressure. So the hydrogen which comes out of from a leak is in atmospheric pressure cannot enter because flow takes place from higher pressure to low pressure, not from low pressure to higher pressure. So the motor body will be slightly higher pressure than the atmospheric pressure. This higher pressure is maintained by either the industrial compressor air or nitrogen. So these kind of precautionary measures are taken, and these are mandatory also in zone 0 area. So for example, I'm telling this. How do you identify the hazard from the labels? You would have noticed this label in many carrier, that is truck, that is chemical carriers, all these things. So if the red color, so 4 squares are there in a bigger single square, the red color, it indicates its flash point. So 0 means will not burn. 1 above 200 degree Fahrenheit. 2 here number 4. 4 means below 73 degree Fahrenheit. That means flash point is very low. Easily it is flammable. As far as health hazard is concerned, this 0 is normal and 3 is extremely danger. So you should be very cautious. Reactivity, here it is 2 is given. Violent chemical change can happen. At 0 it is very stable. 2 violent chemical change may happen. W crossed. What does mean? Specific hazard. It indicates oxidizer. Whether it's oxidizer means OX will be there. Acid means acid. Alkali means ALK. Corrosive W cross mean use no water. Maybe the chemical may be water reactive. So you should not, in the event of spill also, don't use water. These are the communication given by this symbol. This symbol one must be knowing. Particularly, at least whatever the component we are handling in the individual industry, we should know the symbol for the chemical what we are handling in our industry. These are the protective list of protective personal equipment. We are going to see this in detail also. See, to prevent head injuries, this helmet should be used. Hard hat helmet. These are, it can prevent you from, save you from a head. Helmet shall be specification as per IS standard number 2925. That is very important. Face shield give total protection to eyes, nose, scalp, chin, etc. The acrylic blue face shields are used for viewing burner. See, in the face shield, if it is blue in color, normally the industrial heater or furnace, to see the pattern of the flame, we use that blue color shield. And remember, eyes are rationed, only true to your lifetime. So wherever it is applicable, use the goggles or face shield. If once happens, once we lost, that's all. It cannot be replaced. Earplugs. Earplugs, the purpose of earplugs is it can reduce the noise level by 15 decibel. That is very important. Whereas the ear muff, it can reduce the noise level to 30 decibels. So in the noisy area, some equipment is very noisy, means always use either of these to reduce certain level so that your ear will be saved. Remember, the damage happen in the hearing ability or ear is a permanent one. Suppose you can observe some people who are coming from industry always try to keep their volume in the television or anything at higher side than the people available in the family. That means they are always exposed to higher noisy area. Whatever the damage happens to them are permanent. It will not, it can, even you come out of the noise area, it will not retrieve. So that is very important. So you use this air safety measures very regularly, properly. These full body harness or safety belts one must use whenever we work at higher elevation. Higher elevation, what is the definition for higher elevation? That is also very important. If we work above 2 meters level, it must be used. For any work, 2 meters above means we should use. Leather gloves, PVC gloves, cotton gloves, and electrical gloves are there. Appropriate gloves should be used according to the requirement of everyone's occupation. SCBA. What is that SCBA? Normally it is pronounced as SCABA. SCBA, but pronounced as SCABA. Self-containing breathing apparatus. The cylinder hanging on the back of the person contains compressed air, and at the bottom of this one cylinder, a regulator valve will be there, and he can open. A pressure gauge will be there. That air will be supplied through here, and it will go, and the completely his face will be sealed so that no, the outer atmosphere environment air or gas will not go to his nose. Only the air from the cylinder will go. So using this, suppose any hazardous or poisonous gas spread in a particular area, using this one can enter the area, and if require rescue a person or isolate a leaky source, that we can do using this one. But remember, one cannot use this more than 30 minutes. 30 minutes, pressure in the vessel is very high, 200 bars. 200 bars, how do you interpret that 200 bars? For example, that is our car tire. Say if you keep 25 psi pressure per square inch pressure in a tire, that is slightly less than 2 bar. 2 bar. A car tire pressure is slightly less than 2 bar. The cylinder contains 200 bar pressure of air. So then you just extrapolate the intensity of the pressure here. That much pressurized air can be used for a duration of 30 to 45 minutes only, depends upon the size of the cylinder. That is very important. Safety surveillance. So safety is there, everything rules and regulation we have given, but unless some audit is taking place, we will not follow. So safety audit, safety survey, safety inspection should be taken care at periodic time period, periodic fixed frequency, not only by the owner of the unit, that the person belonging to the particular unit, other cross survey, cross audit should be taking place. A person from the process unit of X should come and audit the unit Y. This person should go to the Z. In the cross audit, such a way cross audit should take place. Then only we can upkeep all the required safety equipments in proper manner. Inspect all PPE prior to using each time. If any part of the PPE is damaged, seek repair or replacement. Store all PPE in a clean, dry and secure place. That is very important. You heard about MSDS, Material Safety Data Sheet. Material Safety Data Sheet is nothing but whatever normally in any industry we use either acid or alkali or some other oil or some solvents kind of thing. This kind of different chemicals we use. So the person who is handling that material should know the property of this material. One. Secondly, if any accidental contact on the skin, eyes, mouth happens, what should be the first aid action one should take? That also the person who is going to use this must be knowing. So all these things are in a detailed manner given in material safety data sheet, that is MSDS. Familiarize with the health hazard of chemical, safety measure to follow in the event of accidental skin contact, eye contact, inhalation should be clearly described in the board. Familiarize with the first aid treatment for the above events. That is very, very important. Sorry. Investigate. Develop a habit of reporting all incidents to the appropriate authority. One. Second is investigate all incident and accidents, whatever the magnitude of it, whether it's small or bigger. Today it may be small, tomorrow it may become a very bigger one. So we should analyze what was the cause, how we can avoid this in future. That should be analyzed, and whatever the result comes out of the analysis, that should be disclosed to the employee who are working in that area. That is very important. Accident and injuries resulting in medical treatment must be documented on an accident investigation form as per OSHA standard. Okay, we will see a case study. Many of you would have heard Chhattisgarh, one in aluminum industry, aluminum manufacturing industry. I don't refer the name of the company. In aluminum industry, of course, it is not controlled by them now. It is another private party has taken over. Korba chimney collapse. Many would have read in September 2009. This chimney was constructed. Chimney means a provision for letting out the flue gas or the contaminated gases or the product of combustion. That is carbon dioxide or any ash, anything will go out through that. Plan was to construct a 275-meter height chimney. It has reached a level of 240 meter. On that fateful day, a lightning struck on this chimney, and suddenly it collapsed and fell down. What happened? The National Institute of Technology experts were called and pressed to analyze the incident. After analysis, they said NIT very substandard quality and technically fault in design. Substandard quality of material, technical fault in design itself was a cause for the collapse, they mentioned. And also during construction, normally in the cement work construction, people used to pour water for curing. That is for saturation of its reactant. That is curing. That curing was not done properly. Soil at that site was not up to the record code level. That is to withstand that a large height, that means large mass on a small place. That soil is not suitable for that. 45 deaths recorded, 45 life we lost. Supervision and monitoring was found to be negligent. You would have read in the news items, the in charge for that construction site was beaten up to death by the angered laborers of the site. So anywhere, supervision, inspection is very, very important for safer design or safer construction. This core one. And another case history, it's a Jaipur fire terminal incident in the same 2009 year. Petrol started to leak. It was told that naphtha and petrol also they mentioned started to leak from a pipeline in a Jaipur oil terminal. That oil started to leak and got accumulated in the entire area of their bund wall, that is in their periphery. Nothing could be done to stop the leak even in spite of their repeated attempt. So large vapor cloud because of the vaporization. Flashpoint is minus 42.8 we discussed for gasoline, petrol. That much low flashpoint material. Lot of vapor generated. During that time they started one diesel generator. The exhaust of the generator, the heat at the exhaust of the generator caused a ignition source for the vapor and the entire area was in flame. The fire was put off by starvation. What is starvation? That is after exhausting all fuel only the fire was put off. Almost large number of tanks got damaged in that. It was told that the sound heard up to 32 kilometers away from the site. 32 kilometers. So the carelessness or disobedience to the safety norms will end up to a big loss. Who moved my oxygen? Fire is oxygen that you must be knowing. You must aware of it whenever doing the firefight. Because the firefighting crew will be always focusing to put out the fire at the front. But when it is in flame, it consumes the oxygen in the area. When it consumes in the oxygen in the area, normal oxygen level is 21% in atmosphere. This oxygen percentage, oxygen concentration is a frequently used word since the last February in the corona situation. Oxygen level, everybody aware of it now. So during the fire also, if the atmospheric oxygen is consumed fully, the leftover oxygen available for the firefighters to breathe is in lesser concentration. That will make them to giddiness and sometimes to collapse also due to some lungs problem and all. So the one person should be always stand behind the firefighters to guide them, to advise them, to rotate the person who is in the front side of the firefighter. One person will be there after every 3 minutes or 5 minutes. 5 minutes withstanding in the front line is very tough. 2 to 3 minutes you should ask him to come out and another person should go to front. In such a way it should be rotated. That is very important because oxygen will be less in that area. Burn degrees, first degree, second degree, third degree, we used to call it. Redness and skin and is least serious is first degree. Causes red and blistered skin, second degree. Worst to burn and cause white or charred skin. It's important to burn correctly. So this is second degree, third degree. Whatever the level of the burn, whatever the degree of the burn, apply lot of hold water on the burn injury area so that the heat will not penetrate to cook the flesh inside our body. Very important to cool that area, water should be applied. Cool the burn area with cold water at least for 10 minutes, seek medical treatment. Protocol, what is protocol? Describes action that must be taken to ensure employee safety in emergencies. It must be clearly written and everyone should be aware of this protocol. Include floor plans, maps which show emergency escape routes. They should follow this set procedure and automatically take the defined role in the emergency. These all we already discussed. Standard operating procedure means every person's role, what step one should take, after which step this step should be taken. Everything will be described in detail. Be well versed with the SOP of each equipment of the industry. Bypassing of any steps of SOP must be authorized by the appropriate authority. Depends upon the situation, one should not indulge in bypassing the standard operating procedure steps unless it is authorized. Personal safety during firefighting operation. The fire crew stationed in a hazardous operation should have an observer that we already discussed. Wherever necessary, men should be protected from radiation heat by shields and water spray. This is very important. The person may be approaching the fire seat in the front line. The radiation impact will be very high. To safeguard him from the radiation, a water screen, that is using the water hose at the end nozzle, we can adjust the nozzle to make the water spray like a screen. If it is spray like the screen and if we keep this in front of that person, the radiation impact on that frontline person will be less. That should be taken care. Very important, relief and refreshment should be arranged at frequent intervals. The person who is in firefighting will be exhausted and dehydrated. So very frequently, refreshment means water, buttermilk, or anything else like that should be supplied to him at a frequent interval. Frequent interval, very important. Breathing apparatus should be worn to protect against toxic gases. Fire entry suit shall be used by trained and experienced persons only. Points to remember. The most important but the most unacceptable points to many of us is fire takes place due to carelessness and ignorance. That is a proven one, though we have hesitant to accept it. Carelessness and ignorance is the causes for the most of the fires. You must be knowing your fire call number, your industry or local area fire call number. Fire prevention rules should be followed. Report all fire. Don't tamper with firefighting equipment. Be sure that know how to use the firefighting equipment. Ensure that firefighting equipment installed in your sections are preeminently located and easily accessible. If you suspect and defect the firefighting equipment, replace them immediately. The used fire extinguisher should be replaced immediately. This is very important point. Sometimes in a process unit or any industry, for a small fire, one of the employee would have used a fire extinguisher. If it comes to the notice of the top management without appropriate reason, it was used. If they feel like that, they may say something different. So let us not disclose it. We'll hide it. The such tendency will come normally. To people, such tendency will come. But if a real emergency arises, it will not be useful. So report every action activities. If it is used, report it, replace it. Even in inadvertently used it, so it should not be mined by the management. Suspend all hot jobs when fire siren is raised. Use the fire hydrants without. Fire hydrants are to supply water for firefighting. Using that water for some other purpose is prohibited. Don't park vehicle near the fire area except emergency vehicle. Another point is a good practice. Leave the ignition key of the vehicles on the dashboard itself. Suppose a fire occurred, people are doing the firefighting, some top management person is coming in a car to inspect the area. He parked the car near that area, but he should leave the key in the car itself. Because if suddenly very seriously it developed, the fire scenario developed, and the environment is very badly affected. somebody in the area can move the car away from that scene. The key is not there, it will be difficult. So in a fire scene, if anybody comes to a fire scene, a habit should be developed to leave the ignition key in the dashboard itself. If it's not a practice, that practice or procedure should be developed like that. Don't use fire station for telephones for other calls. Don't spread rumors, that is very important. Constitution of India provides detailed provision for the rights of the citizens, safety and health risks at workplaces, and to provide measures so as to ensure safe and health working conditions for every working man and woman in the nation. Constitution of India clearly specify the role of government as well as the industrialists to ensure the safety of its employees. Fire safety at factory, on-site emergency, off-site emergency, we have already discussed. That is mock drill. Why emergency plan? To maintain objective of an emergency plan or to control and contain the incident and accident, and if possible eliminate it. To minimize the effects of incident on persons, property and environment. See, fire operating manual or fire safety manual should be available to the reach of each and every employee. Every employee should go through it and they should be familiarized with the procedure on it. The protocols, mock drill guidelines, all guidelines you must be knowing. And you all must know safety. If you know safety, that is KNOW safety, there will be no pain. In other words, if there's no safety, NO safety, we will come to no pain, KNOW pain. So if you know safety, no pain. If no safety, we will come to pain. Always remember, work safely, for the most important people in your life are waiting at your home. That is your family. So that is already we discussed that firefighting is some other say work, not our work. We should not think like that. Everyone should maintain safety. With one word, I will conclude. We have a lot of ID cards like Aadhaar card, PAN card, ration card, driving license, master visa cards, many cards. At least in if you take your wallet, more than the cash money, the plastic money will fill it more than that. All these cards are valid. How long all these cards are valid? Till the person alive. To the person alive, one should follow safety without any deviation, very strictly all the time. There is no holiday for following safety procedures. Thank you all. Now we can start a question session. Mr. Ujwal.
Yeah, thank you, sir. Just I will ask you the first question, sir. What is the difference between the working fire watcher and non-working fire watcher?
One second, please. Working fire watcher.
Yeah. What is the difference between the working fire watcher and non-working fire watcher?
Non-working fire watcher. Two things are there in this. We discussed about active firefighting and passive firefighting. Passive firefighting is the system inbuilt in the unit itself or the facility itself or the industry itself. So in the event of fire also, this system will protect the most important equipments. Like this, non-working fire watcher is your CCTV camera. And the person who are not belonging to the actual firefighting department or the person who is not working in that area. Say consider security or a nearby industry person who has watched from his watchtower, some fire is there and he is communicating to you about this. These are non-working fire watchers. And working fire watchers, this I presume only, this word I have not come across, but I presume that this is the thing. Working fire watcher is people who are working in the fire section, firefighting section, and those who are working in the belonging to that process unit itself.
Okay, sir. Second question is please explain your UFL and LFL.
UFL and LFL. See, for any fuel to burn, it should have some composition or some percentage. That is its explosivity or flammable range. We call it as a flammable range. Lower explosive limit or upper explosive limit, some people are calling. Some people are calling as lower flammability limit and upper flammability limit. Limit or level. In various books uses different words. So when for example, if you take diesel, a common fuel we take. Diesel, its flammable range is 0.6% to 7.5%. What does it mean? If diesel vapor, already we discussed that any fuel which burns, it involves in the process of burning, it burns in the form of vapor only. After converting into vapor form only, it is burning. Even wood also by heating, the vapor releases from the wood and that gas only catches fire. Like that in the diesel, the 0.6%, suppose that's why to simplify that only I mentioned as 100 milliliter instead of saying in percentage. So now we'll discuss about percentage. If 0.6% of this atmospheric air contains diesel vapor, then the diesel is sufficient enough to get ignited. Otherwise, what happens if it is less than 0.6%? What happens? The diesel is too lean or it is insufficient to catch fire or sustain the fire because oxygen content is very high. Combustion is a chemical reaction. For any chemical reaction, the equation should be balanced. In this manner only, it is catching fire. Likewise, if it goes above 7.5%, then what happens? It occupies more volume in the atmosphere. So naturally, the percentage of diesel increased in the atmosphere is reduced in the concentration of oxygen. The component volume, everything, the mass is fixed. You cannot alter it. Only you can vary it. So this oxygen percentage is not sufficient enough to ignite the diesel vapor when it goes above 7.6%. So from 0.6% to 7.6% only when diesel vapor is available, it will catch fire. Otherwise, it will not catch fire. This is a flammable range. We call it a flammable range. The example of other critical example is hydrogen. Hydrogen flammable range is very wide, from 4% to 75%. So the most easiest way a fuel can catch fire is hydrogen. That's why in the zone 0 area also I mentioned about hydrogen, because in any range it will catch fire from 4 to 75, very wide range. Whereas other fuels are very narrow range, 0.6 to 7.5, like that. Carbon monoxide, it is one more oxygen it can consume to modify to carbon dioxide. At least 12% of carbon monoxide presence only will catch fire. So this range is the flammable range. That's all. Ujjwal?
Yes, sir. The next question is rim seal protection is required for HSD tank.
Yeah, HSD tanks, that is diesel. The question is from refinery employee or any other else? Petroleum refinery employee? May I know the question is from petroleum refinery employee?
Actually, I have to search, sir.
Okay, no problem.
Beverages.
Okay.
He is from the beverages. Yeah.
From?
He is from the beverages.
Okay, no problem. Whatever it may be. Any oil, if it can evaporate or vaporize in the atmospheric temperature and pressure, if you store it in a open vessel or with only a covered at the top in such a way, if you store it, Due to the evaporation and vaporization, loss will be there. One. Second point is, this vaporized gas goes to atmosphere, it pollutes the atmosphere. These two factors can be prevented by using floating roof tank. That is, the roof will be floating, touching the oil in the tank. So when the level goes up, the roof also travel along with it, and goes down, it will the roof will also go along with the level. So to ensure the free movement of this roof, there will be a minimum clearance gap between the tank shell and the roof outer periphery. So the gap is enough to produce vapor, and it gets accumulated on the top of the roof. Of course, there are sealing systems in the foam kind of sealing systems are there. In spite of that, some vapor will come and accumulate on that roof. So if fire catches due to lightning or any other due to any other work taking place when oil is there in the tank, it will be a disaster. To prevent that, rim seal protection is advisable, but mostly for petrol, naphtha kind of tanks only this is used. But people are using in diesel tanks also. Thank you. Next.
Next question is, in petrol pumps mention not to use mobile phones, but nowadays we are using digital platform payments. Is that safe to do so?
Digital payment, normally what they say, while using the phone for talking, conversation, only that higher energy is released from the phone. For taking the receiving the message like OTP or to use your debit card, this is not that much hazardous. That's what they decided. Even in spite of all these things also, we are seeing people are using the mobile phone. Even the people working in the petrol pump itself, they are working the mobile phone. So all the time it doesn't occur. When it occurs, a few cases or case histories are there. This all happened because of using this mobile phone only. So that was banned. These other things that the signal level as well as the emission level from the phone is higher while the conversation takes place. That's the reason they are saying. Strictly speaking, we should keep the phone out. We should not use like that only. Or that debit card, everything system should be kept outside the boundary of the petrol pump. Like that, it should be done. But such a guideline should be developed for that.
Sir, what is the difference between flashpoint and firepoint?
Flashpoint and flashpoint,
Firepoint.
firepoint.
Firepoint. Sir.
Ah. See, flashpoint, I already mentioned for gasoline or petrol, the flashpoint is minus 42.8 degrees centigrade. What does it mean? That is that for minus 42.8 degrees centigrade itself, it can evaporate and some kind of some vapor can be formed. That petrol vapor can be formed. If you ignite that vapor, it can catch a momentary flame, but that temperature is not sufficient to sustain the flame continuously. It will catch fire, but immediately it gets put off. Automatically it gets put off because it continuously not burning because the temperature is not sufficient. So the flash point is the point at which a momentary flame occurs but does not sustain continuously because the temperature is not sufficient. Fire point is the point where at the temperature at which the vapor catches fire, and even after you remove the ignition source, it will continue to burn. For petrol, flash point is minus 42.8 and fire point is around 216 degrees centigrade. See the difference, wide difference. So this is what difference between flash and fire point. Fire point, if you reach the temperature of fire point, then there is no need of ignition source. Flash point is not like that. Okay.
Yeah, the next question is, what is the difference between primary escape route and the secondary escape route?
Primary.
Primary escape route.
Escape route.
Yeah, and secondary escape route.
Primary escape route and secondary escape route.
Yeah.
Normally, primary and secondary escape route, I don't think it is classified like that. More than one escape route must be there. That is the exit point. And all these points should be direct the person who is using that route to reach a safe point, where it can be a emergency assembly point, it can be a emergency assembly point, or a safer location to reach. Primary and in the escape route, normally it is not distinguished like that, I think. If I will try to check once again for this question. You just inform that person who raised this question, I will confirm and revert to him.
Yeah. Okay, sir. I will check soon.
Okay.
Our next question is, what should be the minimum distance of safe assembly area from building? Are there any standard for defining sufficient area required for safe assembly area?
Safe assembly area depends upon the business they are doing. Suppose it's highly explosive items they are using, the distance will be far away. Suppose it's a small, sorry. Suppose it depends upon the stocks of the flammable material available, hazardous situation of that area. Then based on that, the distance is kept. In a administration building or in a mall, safe assembly point will be just immediately outside the building. In a industry also, the administration building where it is located in the industrial premises, that administration staff assembly point will be immediately outside the building. Whereas in the process unit where large quantity of hazardous chemicals as well as flammable materials are handled, their assembly point is minimum 50 meter away from that location. Like that it is kept. That is depends upon the facility being used for what. Like that only, based on that only it is decided. Yes,
So
you have
what is the simple calculation for fire load?
fire.
Fire load.
Fire load calculation I will revert you.
Yeah. Okay. Kedarji, I will mail to you.
Okay.
Okay. Yeah. The next question is, while filling LNG in vehicle pump, why are passenger asked to step out of the vehicle?
While LNG filling,
Yes, sir.
see, even while filling petrol also in the car and two-wheeler, you would have observed some private pump operators are asking the people to come out of the vehicle. Yes, once in the course of discussion, I mentioned that one static electricity. Do you remember? If I said you may be aware of this, so I am not discussing about static electricity. In any pipeline, that is, it's a hose or metal pipeline, rubber hose or metal pipeline. If you admit some flow, it moves not in a bulk quantity. The phenomena of liquid traveling is moving by a layer over a layer. There is one layer of fluid will be going, and above that another layer is going, and above that another layer is moving. So each and every layer is put together to form a stream of flow, whether it's a petrol or diesel or water or LNG. When you compare the velocity of that flow, the fluid which is touching the inner wall of the pipe or the hose, the velocity of the fluid touching the inner wall of the pipe will be less compared with the velocity of the fluid which travels at the center of the pipe. This is a fluid flow phenomena. This is called as boundary wall phenomena. That is the fluid which is touching the inner boundary. That is boundary wall phenomena. Normally, velocity at the boundary wall will be 0. That is, the fluid is sticking to the wall of the tube inside. It is almost 0. When we move towards the center of the pipe, the velocity increases and the actual velocity we reach. When different velocity, different layers are moving, there will be a frictional force between each layer. And suppose 100% every component is uniform, that is, you are filling LNG, all the components are only LNG without any mixing. Here, I don't mean that mixing is as adulteration. In the production itself, say for LNG, you consider LNG as C1, that is methane gas. Some small percentage of C2 and a very smallest particle of C3, that is ethane and propane may also present. When at a different layer and sometimes some kind of this one water particle may also there. So when different component moves in the same layer, due to the frictional energy, one static electricity form. Because of friction, some electricity component forms. That is a potential difference between two rubbing components. If the potential energy created, there is a possibility of creating a spark. If it sparks, some inadvertent incident may happen. Because of that only, even filling in the petrol in the car also, if you are sitting inside the car, close the door and keep sitting. If you are opening the car, come out. Don't open the door and keep one leg on the floor, 1 foot on the floor and 1 foot on the car. Then your body is used as a conductor to conduct the static electricity. Then you will be get burnt if the accident happens. That's why to avoid that static electricity only, if anything happens due to static electricity, people are asked to come out. Okay.
Yes, sir. What is hammer blind?
Hammer blind.
Yes, sir.
This point we have not discussed at all here. Maybe the person would have catch this point from Jaipur incident. See, the Jaipur
Yes, sir.
incident we discussed, in which you consider that normally blind means, don't take the literal meaning. In the industrial meaning, blind means a blank plate. That is, if you pipes are connected by welding or by flanges. In between the flange, if you insert a blind plate or blank plate, that means you are stopping the flow. You will not allow any flow. The other end of the other side of the there is this plate is inside. The other side of the same plate will be a center, a hole will be there, one ring kind of thing. So it will be in the shape of 8, number 8, with one circle is fully filled and another circle is blank. So that only filled material is going inside, it will obstruct the flow. So that is for purpose only. For the purpose only we are using the plate. If you reverse it, the plate which contains the hole will go inside the pipe, so it will allow flow. This is a normal figure 8 blind plate normally in industry used. To improve the system, one design was developed as a hammer blind. What happens in the hammer blind? Instead of opening the flanges, opening flange means you have to use a lot of energy, your tools, spanners, gaskets replacement, everything will be there. Instead, what they developed, 2 isolation valves are provided. You consider there is a 24-inch diameter pipeline. In the 24-inch diameter pipeline, 2 valves will be there. In between, this I mentioned, no, the figure 8 plate. Like that, a strong thick plate for about 1.5 to 2-inch thick plate will be there. Very strong material. So after closing both sides wall, you have a leverage system to lift the hammer. This is called a hammer blind. Lift this number 8 plate and you can rotate downward or upward according to your requirement. If you want to admit flow, you downward, you push down the whole provided plate, and if you want to stop the flow, you provide the blank plate at the bottom of the pipe. Like that, you can rotate. After placing this, to prevent leak, one rubber o-ring, there is a circle ring, o-ring used to be called. The rubber ring will be seated or fixed to the hammer blind side, and it will be treated as a gasket, and it is fixed. After fixing that, both side valve will be opened. Now what happened in Jaipur? They fixed the hammer blind. Then after that they opened the valve, but somewhere due to the problem in the hammer blade, maybe due to worn out or due to the o-ring, rubber o-ring damage, oil start to push out from that flange. It almost filled the entire area. It was very precarious situation. It caught fire and no one could approach that area. So this is the hammer blade. Okay.
Yeah, sir. The next question is, what is the IS standard for wet chemical fire? Can you guide
IS standard
the
for?
IS specification code for the same?
Please repeat the question.
What is the IS standard for wet chemical fire?
Wet chemical fire. Huh?
Yes, sir.
Wet chemical fire IS standard I will refer and tell you, but there is like potassium salts are used. There is the idea is the salt used in the fire wet chemical firefighting is it combined with the cooking oil to make soap. Once it becomes soap, then there will not be any fire. The saponification reaction takes place. That is a fundamental idea. The IS number I will refer and tell you. Okay.
Sir, please mail me and then we will, I will
Yeah,
mail.
definitely. I will
the
mail you.
parts. Yeah.
So, usual,
So,
the
yeah.
questions pending are, what are the questions?
What's up?
Primary escape route and secondary escape route, I will elaborate little more.
Yeah.
One,
Yes,
then
sir.
IS standard, and another one is safe distance for fire load calculation.
Yeah, fire load
Fire load calculation.
Yeah.
These three questions I will
Yes, sir.
I will mail you, and then you can send it to participants. Okay.
Yeah. And the sir, next question is cathodic protection of SCL storage tank. Please explain.
Cathodic protection,
Of SCL storage.
HCl,
Yes, sir.
hydrochloric
Hydrochloric.
acid.
Yes, sir.
Cathodic protection for HCl storage. So, as a matter of fact, the cathodic protection means when two dissimilar metals are used in a system. There is each metal has a property of having conductivity. So, conductivity is measured by Mohs. Normally, in electric system, resistance is measured. A unit of resistance is ohm, the OHM. That you all may be aware of it. So, reverse of resistance is conductivity. Unit is also you just reverse the ohm OHM. Reverse it MHO Mo. That is Mohs is the unit for conductivity. When two different metals or dissimilar metals are used, conductivity of each metal differs. When each metal differs, it starts to act as an electrode, cathode and anode. Like that, it starts to act among themselves when the fluid is present. Here in the case is HCl, hydrochloric acid. What happens? The metal which conducts better will start to sacrifice its or is getting eroded and deposit on the cathode metal. So these two metal act as a cathode and anode. It's ought to get deposited on the cathode metal. So finally, what will happen? The metal will get eroded. At one point of time, if it's a pipeline or a storage tank, it will get eroded and a leak will develop and a hole will be developing. It will lead to accident or loss. So to prevent that, the cathodic protection, normally they provide an additional piece of or block of metal which has higher conductivity than these two metals. So what happens when the dissimilar conductivity occurs? The metal which is provided additionally, like a block, a piece of block, is sacrificing itself. It is called as a sacrificing metal. The sacrifice, and it prevents the corrosion of the parent metal. That is the tank metal. That is the cathodic protection, the basic idea I am giving here. Okay. Thank you. Next.
Next question is protein foam is available and used as per Indian standard?
Which
If
one?
so, what?
Please.
Protein foam.
Protein foam. Yeah.
Yes, sir. Is available and used as per Indian standard. Indian standard. If so, what is the IS specification code?
Okay. Protein foam is available and it is being used as per Indian standard only. That much I know very well. The Indian standard number I will revert you.
Okay, sir.
Okay.
What precaution to be taken for stack pot fire while monsoon?
Stack.
Stack pot fire.
Stack caught fire.
Sir.
Stack means chimney or stack that you are referring that.
Mr. Modi, can you elaborate? Please type your question again. Kiran Kumar Modi ji. Sir, it is a vent of hydrogen.
Vent of hydrogen.
Yes. Yes, written vent of hydrogen.
Vent of hydrogen. What is the question?
What precaution to be taken for stack caught fire while monsoon?
Well,
For
monsoon.
stack, for stack, he's written, I think, vent of hydrogen.
Oh, vent of hydrogen monsoon. During monsoon, see, normally in the industry nowadays, these vents are not at all allowed as per the latest standards.
Yeah, he has monsoon means during thundering.
Yeah. Okay. So earlier day in olden designs, vents are there inside the unit. In the process unit also vents will be available. Whereas in latest designs, no vent will be allowed. No hydrocarbon or flammable gas like hydrogen or nothing will be allowed outside. So what they do to prevent the fire incident in the vents during monsoon time, always a purge steam will be introduced in the vent so that it always quench the whether it's a hydrocarbon or a hydrogen, it will prevent that area. That is, the hydrogen will not directly get contact with the lightning or thunder like that. So normally we used to put quench steam. We call it as quench steam. QUENCH. Quench steam to the vent so that will be get quenched. And idea is to make the mixture very lean. That is the basic idea. That is, see, a small quantity of hydrogen is coming. You put excess quantity of some other non-combustible material along with it, so that you make it a very lean one. That is the idea. The quench steam is introduced in the vent. That is the normal practice.
So what should the pressure of gas inside the fire extinguisher?
In the extinguisher,
Yes, sir.
the fire extinguisher pressure inside is varying size to size and type to type. The CO2 type cylinders. More than that, see, for all extinguisher, I have a, detail. I will send to you. You can send it to them. Different types cylinders are using, extinguishers are using different pressure material. That I will send to you.
Okay, okay, sir.
Okay.
I think you have, sir, answered most of the questions. One question is more proper way to store lubricating oil containers.
Lubricating
Proper way to store lubricating oil containers.
oil containers.
Yes, sir.
Oil containers, we should be normally any container, we should store it in a dry place. It should not be wet one. And particularly in the oil container, lubricating oil container, moisture should not be allowed inside. What happens in other oils like kerosene or diesel or petrol, if water enters or moisture enters, because of the density difference, the moisture content will settle down at the bottom. We can remove it, no issue. Because by the density difference, we can remove it, no problem. Whereas in lubricating oil, what happens? Emulsion takes place. When it mixes with water or moisture, emulsion takes place, and because of that, lubricating oil will lose its property, that is viscosity index. That property it will lose. If it loses that property, it will not function as a lubricating medium. So main idea is you should store in a dry place, and at any cost, moisture or water should not enter the container. That is a general idea I am giving.
Sir, the next question is what is anti-static measures?
Anti-static
Measures.
measures are anti-static measures are there is the person who has raised question about the LNG, same person. So okay, Ujjwal.
Yeah, I
Whatever it may
think
be.
yes, sir. I think he is the same person. Sachin
Okay,
Bhuate.
whatever it may be. That anti-static preventing measure is give a earthing system property. That's all. You would have observed that in the loading of loading or unloading of petrol and diesel, you would have seen in petrol bunks. In the lorry truck, they used to move, and while unloading, they used to connect the vehicle by linking a chain with the body of the vehicle to the earth point, so that anti-static electricity, anything is produced, that will be earthed properly. It will not carry on to the next level of creating spark and other thing. So earthing is very important. That's what we can do to neutralize it.
Yeah, I think, sir, Jairaj, sir, you have answered most of the questions, and the remaining questions you can mail me that you have not answered, I think.
Okay.
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 And thank you, sir, for the excellent presentation. Actually, we have got feedback in the chat box, and I have WhatsApp you also that today we have an excellent presentation on fire safety. So thank you, Jairaj sir, and thank you all the participants. And the next class is on 25 from 15 hours. It is on confined space and pressure vessel safety. So please join on 25th, that is Sunday. Okay. Thank you. Thank you all.
Thank you.
Thank you, sir.
Thank you, Ujjwal. Thank you,
Thank you, sir.
NPC. And
Yeah.
I personally thank all the participants for their attentive. They have very focused in the class. I have observed this from your questions you have suited. That indicates that you have observed the class very keenly. Thank you very much. Thank you all.
Thank you, sir. Thank you all the participants. Thank you.
Thank you.